Hey you guys, this is Mr. Sal. We're just going to look at manipulating some formulas for a very specific variable in a formula. So thanks for watching. Don't forget to like, comment, and subscribe. Formulas is just really just manipulating equations. I don't know. It's essentially the same unit that we have in 980. Just, different letters and numbers, and probably more fractions, I guess. So yeah, you can clear all of the fractions by finding the common denominator and then use any distributive properties that you need to combine like terms. Then it's just like solving a regular equation, but instead of using numbers now, we're almost always using letters and numbers, or just letters even, which, makes it kind of interesting. For example, right here, we're going to solve for x. So I need it to be x equals something. That's what it's really asking us for. There'll be a bunch of garbage over here, right? And it's going to look really funky because we're so used to x being some value all by itself. But in this case, we want it to equal a lot of garbage. So what I want this to end up looking like is just 5x to start out with, not 5x plus 3c. So what I'm going to do is subtract 3c from both sides. And I can see right there, there's no other c values to combine with my minus 3c. So I can't combine it other than to show that we're going to subtract 3c. Just like that. There was no c values to combine, right? There's no a values to combine either. Now what I'm going to do is I'm going to divide both sides, or all the terms, by 5. See, that gives me a 1x, which is really what we want. X equals that stuff. That's it. That's as far as we need to go on that. Okay. This is kind of like a y equals mx plus b stuff, but it's written a little different. And we are solving for x, so I don't want 5 mx's plus 7 b's. I just want 5 mx's, right? So on this one, I am going to subtract 7b from both sides. That's a positive y, so I can show that I've got a negative 7b there. Right? We did it to both sides. I'm going to drop my 5 mx. Now I've got 5 mx's, but I don't want 5 m's times that x. So I need to make it a factor of 1 by dividing both sides by 5m. Just like this. And the 5's become a factor of 1, and same with the m's. So now I've got x equals, that's a negative 7b plus y divided by 5m. And now we have solved for x, right? We have x equals something, or something equals just x, and we're good. Alright, I don't know if it's getting more complicated. It's just kind of the reverse of order of operations right here. Could we distribute that 2/5? Yes, we could. But I could get rid of it right now, okay? And to do that, what I'm going to do is it's 2/5 times that stuff. So if I just divide this by 2/5, then it goes away. Alright, but if I do it to one side, then I've got to do it to the other side. So I'm going to take a and divide that by 2/5 as well. And we got to remember back with fraction division. Alright, so since I'm dividing by that fraction, I need to reciprocate it to make it multiplication. So it's really a times 5/2. And now this equals, right, the 2/5 cancels out with this divided by 2/5. Anything divided by itself is 1.
Wait, so step 1.
Well, that equals by plus m. And yeah, we could rewrite this as 5a halves. But what I really want to do right now is subtract that m from both sides. So I'm going to subtract m, and now that equals by. But I don't want by's, I want just y. So right here we'll divide both sides by b. So I'll just show this is divided by b. I'm kind of okay with that myself, right? 5a minus 5a halves over minus m over b. equals y, but I really assume that what they want you to do is divide both terms by b. So we'd have to divide that by b, which gives us a complex fraction. It's not too bad. It just gives us 5a over 2b minus m over b equals y. I don't know. It works. But let's try the distribution way, right? So we'll distribute 2/5 into this set of parentheses. We'll do that over here. So we still got a, but now we got 2by over 5 plus 2m over 5 as well. I mean, we got common denominators there if we wanted just to make it one fraction. I don't know. Well, I don't know. I'm going to make it one fraction, okay? So we have common denominators of 5. So I've really got 2by plus 2m over 5, and that equals a. The only reason I did that is so I could multiply both sides by 5. And that gets rid of the fraction right there, okay? So now I've got 5a equals 2by plus 2m. Now, when I subtract my 2m from both sides, then we get a little bit closer to getting y by itself. And from here, we'll divide both sides by 2b. But again, I'm just going to make it so I'm dividing everything by 2b. And that gives me 5a over 2b. And I can cancel those 2's out, so it's m over b equals, those 2's cancel, and same with the b, it's y, just like we had before. I don't know, just to go back to this one step right here, if you made that one fraction, I would be okay with that myself. I'm not sure if the homework would be something like this. If you had written like that in black right there, I would be okay with that. This is kind of old-fashioned right here, circumference. 2 pi times the radius, and we'll solve for the radius, which just gives us a nice little formula on that. And to solve for the radius, I'm just going to divide both sides by 2 pi, right? So the 2's and the pi's cancel out, gives us radius is the circumference divided by 2 pi. Some of you guys knew that already. And that was kind of a quick example. Alright, this is the formula for finding the area of a trapezoid. Not that you guys care. But it still works, and we can solve for a. And the first thing I would want to do is get rid of that 1/2, and then I'll get rid of the h instead of distributing it, okay? Not that it would really matter if you did that. So to get rid of the 1/2, I'm going to multiply both sides by 2. So now I've got 2a equals the height times the length of one side divided by plus the other side. Those are the two parallel sides for a trapezoid, by the way. We'll divide both sides by h. Could you distribute? Yes, you could. Either way, though. So the h's cancel out, so I've got 2a over h equals a plus b, and we're solving for a. So right here it appears I need to subtract b from both sides. Now b doesn't have that denominator of h. So it's really 2a over h minus the base equals the other base a. And that's it. If by chance, because I'm trying to think, if you did that, if you distributed the h, then you probably ended up with something like this. 2a minus bh over h equals a. I'm okay with that. This one wants us to solve for e, which is in the denominator, and we're pretty close here to having common denominators for all the terms in this equation. And in equations, when we have the common denominator, we get to ignore them, right? So while that's 7 over 1 right now, I'm going to make it e. So I'm going to multiply the 7 by e as well, okay? And yeah, I don't really need the 1 there. So that gives me common denominators of e throughout this entire equation, which allows me now to rewrite this as a new equation but without any denominator. So c minus 7e equals 4g. Well, some of us feel pretty good already just by getting rid of those fractions. Solving for e at this point isn't too bad. We'll subtract c from both sides. And then I just need to divide everywhere by 7 so that I have just the e. E equals... Oh yeah, thank you. Thank you. Let's make that a -7 right there. Which means that we could write this two ways as well. So I got 4g minus c over a -7. Or if you wanted to, you could take that negative and distribute it into the numerator. So -4g plus c over +7. Again, I'm okay with both, so this is an or thing. Now we're back to solving for x. Not too bad. Well, here's what we're going to do. I mean, some of you guys would want that to be y over 1 and use cross multiplication. That's essentially what I'm going to do. That's 2 minus x, so if I multiply this side by 2 minus x, and I multiply the other side by 2 minus x, I essentially did cross multiplication right there, okay? Because the 2 minus x's cancel out here. So we'll rewrite this. And, well, we're solving for x, so, I don't know, we could divide both sides by y if we wanted to. Let's say that we wanted, we didn't realize that, and we distributed it anyways. That's okay. 2y minus xy equals 9 now. I don't want that 2y there, so I'm going to subtract both sides. Subtract from both sides 2y. And I won't forget the negative this time. Negative xy equals 9 minus 2y. And now I'm going to divide both sides by negative y to get the x by itself. So divide by negative x. Oh man. Y. There we go. Now I've got x equals 9 minus 2y over negative y. Or, again, I could write this differently. Negative 9 plus 2y over y, or even further, not that you guys care, but you could have written this as negative 9 over y plus 2.
So that negative y.
Alright, this one's a little different. Still solving for x though. And once again, we have an equation. We're not really as close as we were with the e problem, but if we have common denominators throughout, then we'll still be in good shape. All right, so we have a t, x, and an n in the denominator, all three denominators. But if we can make each denominator x or txn, then we're still in good shape, okay? So the t, I'm going to need to multiply that by x, but I need to multiply in the numerator as well. So that gives those an x in common, but the n also needs an x in common. So I'll multiply that in the numerator also. I guess we can do the t's next. So I'm going to multiply the x by t and the 3 by t also, but also the n and the 6 right there. So that gives us a txn there. Finally, what we need is the n, right? Still multiplying in the numerators also. We already have the n there. So I'll rewrite this out with the denominators. And now we have those common denominators. But again, we can rewrite this without any denominators since they're all the same. Well, I'm deep into it.
Can you just divide?
So I want all my x's on one side of the equation, which still isn't too bad. Not necessarily. I could divide everywhere by x, but then it gives me new denominator on that. So what I'm going to do instead is I'm going to subtract 6tx from both sides. So that cancels that out. Now I've got all my x's on one side, but it's with two terms. So we got to go back into some factoring for this. Specifically, an x. So if I pull this x out from both of these terms, then I've got x times this quantity. I don't know. I think that was kind of slick. Well, to solve for x now, I'm going to divide both sides by 5n minus 6. And as it turns out, that cancels those, becoming a factor of 1. So x equals that stuff right there. That's pretty good. All right, direct variations is just proportions, right? If something changes in the same way. Really what we're looking at is, I mean, if we look back anyways at fractions, I mean, 1/2 is pretty common. But if I made it 2/4, is that a big deal? Same value, right? Well, what if we made it 1x over 2? It'd be the same as 2x over 4, okay? So whether we have letters or numbers, it doesn't matter. They just need to have the same exact value for these. And this is where our cross multiplication comes in. If we cross multiply these, then it should help us to solve, well, I would call them equations still. Now it's not set up for us though, that's the theme. What's important for us to realize in this wording is that it says it varies directly, because eventually it's going to say that they vary not directly, okay, which is the next part. And we'll get to it, okay? Now if what we saw in that last one, right, was y1 over x1 equals y2 over x2. So I'm going to use this as kind of like my first point, right? X is -5, y is 11. So y is 11 over -5. By the way, the only reason why we do y over x is because that's how we find slope, right? With the y2 minus y1 stuff. And then we have the other one. We have the x value, which is 5. We just don't know what the y value is, so we just plug that in right there. So this is our equation that all we're going to do for it is solve for y. Now, if we use cross multiplication, I got 11 times 5. And this should equal the other cross multiply, -5 times y. 11 times 5 is 55. And now I'll divide both sides by -5. Right, that gives us 1y. Y is -11. So that wasn't too bad, I guess, because they gave us the same, essentially the same denominator. We just had to change the sign, where the sign was. Yeah, yeah. So the proportional constant k, which is also the in-proportional constant, which we'll get to. For proportionality is y divided by x. Y divided by x. I don't like that method because of what we're going to see next. Yeah, and if I went back to compare those, right? 11 over -5, and I'd just be checking my work at this point. Does that equal -11 over +5? Yeah, it does. It has the exact same value, which is what proportionality or direct variations need, is the same value. So this is indirect variation stuff where we kind of need the k thing, all right? So if we can just remember k with this, then we're in pretty good shape. Indirect variation means that, right, actually let's go back to direct variation. Or direct variation indicates that if something changes, another thing changes proportionally with it. One example of that is by getting paid per hour. If you get paid $5 per hour, if you increase your time, then you increase your pay, right? Indirect variation is the opposite. As something increases, then the other is likely to decrease, okay? For example, gas and time driven. The longer you drive, the less gas you're going to have in the tank, right? So that's an inverse proportion, or an indirect variation is what they're calling it here. In any case, we will have to solve for the k value, which is the constant of indirect variation, or indirect proportionality, whatever you want to call it. So when we see an example like this, y varies inversely, so it's not directly anymore, it's inversely. So the x and y is one were to increase, we would expect the other to decrease, okay? So we do need to find that k value first. and k is x times y. And right here we have an x value which corresponds with the y value. X is -5, and then y is 10. So I got -5 times 10, which gives us an indirect constant, proportional constant, whatever, of -50. Well, why is that important? Because it tells us to solve for y, and y, as we saw in that last slide, is k over x. We got a k value of -50, and our x value is 4. 4, there we go. And -50 divided by 4, we'll just say -25 halves. What is that, -12.5 if you want the decimal. Either one will work. I don't know. We got to include this problem. I've never seen a textbook that doesn't have this problem. I don't know what it is, okay? But it's always in there. This is kind of like one of those work problems that we did at the beginning of 5.5. And that's okay, whatever. It's just solving. R1 would be the amount of time it takes someone to do the job by themselves, right? Whatever. So to solve this one, well, I would want common denominators myself, once again. So to do that, I'm going to need an R, R1, and R2 in all of the denominators, okay?
So we can't just do our.
Yeah, I apologize. I should have mentioned that. So R sub 2, I mean, you could call it base 2 if you want. Just indicates that it's a second R value. If that 2 was up in the top right, then it would be R squared. I don't know if that makes it easier or not, but whatever. Well, I need to multiply R by R1 in the numerator and denominator, but also the R2 also by R1. And I need to multiply R1 by R, so 1 by R also, and R2 also by R. But I need to multiply R by R2, so in the numerator as well, right, a factor of 1, and same over here. Well, that gives me a common denominator. It's a little sloppy right there, right? I hope the colors kind of help. Let me rewrite this then. Okay, a lot of R's going on right here, but we have common denominators, which is what we wanted, which allows us now to rewrite this, but without any denominators, which we hope is kind of helpful. Okay, well, we need to solve for R1, so I need all the R1s on their own side of the equation. So I'm going to need to subtract this R1 times R from both sides. So let me go ahead and rewrite this now, but this is canceled out. This is 0. And at this point, I'm going to factor out from both of these an R1. So we have R1 times the quantity R2 minus R, and this equals R2 times R. Yeah, just like that other example that we saw, we'll just need to divide both sides by R2 minus R. R2 minus R. And that will equal, yeah, this one cancels out now, and we're left with just R1. There it is.